Point we will talk about is physical properties of monosaccharides. They are crystalline solids. They have a sweet taste. They are soluble in water but not in organic solvents. It means they dissolve in water but they don't dissolve in organic solvents. The chemical reactions of monosaccharides, or what you call it, the chemical properties. Glucose and fructose, or monosaccharides in general, they have maybe aldehyde or a ketone. That's why they can be oxidized or reduced. So this is the aldehyde group. You can write it C double bond OH or CHO. Oxidation of glucose, it means oxidation of aldehyde to the carboxyl group. So this is the oxidation. We need soft oxidizing agent because this one C double bond OH, this H can be oxidized easily as it is terminal and contains H. Oxidation, here you have to insert this oxygen or change this H to OH. Just insert this one between carbon and hydrogen. Change hydrogen to what? To OH by inserting this oxygen. This oxygen is produced by the the reacting bromine in the water. We call it bromine water. Here we have bromine inside the water. This one is soft oxidizing agent. We need soft oxidizing agent because glucose has aldehyde group and it has hydrogen atom, and this hydrogen atom can be oxidized easily. You have to memorize this word. What is the word? Oxidation of glucose. Give us what? Yes, this compound, it is gluconic acid. So this is gluconic acid. It comes from the glucose. Oxidation of glucose give us gluconic acid. Just you have to change the functional group only, but the rest of the compound, they are the same. The second reaction, it is the reduction. Oxidation, add oxygen. Reduction, it means add hydrogen. Okay, so if you add hydrogen, you have to add hydrogen to this bond. You have to break the bond between oxygen and carbon. We have two hydrogen atoms. Add hydrogen to oxygen and another hydrogen to the carbon. So this is the hydrogen is added to the oxygen and another hydrogen is added to the carbon. You can write it CH2OH also. So reduction of glucose give us sorbitol. We call it what? Sorbitol. So this the compound is sorbitol. So you have to memorize these names. Reduction of glucose give us sorbitol. And oxidation of glucose give us, yes, gluconic acid. We can write them in this structure. Okay, look now. This is glucose. Because I have 4 times of CHOH, so I can put them like this one. CHOH by 4, it means this one repeats 4 times. And the functional group for the glucose is the aldehyde group. This is between the boxes. Here it is in the box. Just you have to change the functional group. In the oxidation, this one CHO changes to COOH. So this is gluconic acid. Oxidation of glucose give us gluconic acid. Reduction of glucose give us sorbitol. Okay, what will happen here? Yes, we add hydrogen in amalgam. Amalgam, it means putting sodium with mercury. Okay, so here we have to add 2 hydrogen atoms. One 2 oxygen and 1 2 carbon. So this one becomes what? CH2, and then what we have? OH. So this one is alcohol. Reduction of aldehyde gives alcohol, and oxidation of aldehyde gives carboxylic acid. But in the name glucose, oxidation of glucose gives us what? Gluconic acid. And reduction of glucose gives us what? Sorbitol. This is very important point. Yes, you have to choose from the brackets oxidation of glucose or reduction of glucose. Oxidation gives us gluconic acid. Reduction, we know we have sorbitol. What about the oxidation of fructose by strong oxidizing agent? Why we need strong oxidizing agent, but in the in the glucose we need soft oxidizing agent? Because in the fructose we have C double bond O between 2 carbon atoms. So we need periodic acids as a strong oxidizing agent. You have to break this bond between carbon 2 and carbon 3. Then you have to change this one C double bond O and CHOH, and this one CH2OH to COOH. So again, break the bond between carbon and this carbon, carbon 2 and carbon 3. Okay, then you have 2 compounds. The first one, this is the first part, and this is the second part. You know, the atoms between the boxes here, all of them change to what? To COOH. So this is COH, this is COH, and this is COOH. Okay, now this is a compound, this is acid, and also this is acid. This one you call it glycolic acid, and this one you call it the tartaric acid. So this is the structure of the tartaric acid, and this one the structure of the glycolic acid. So oxidation of fructose gives, yes, 2 compounds, 2 acids, because we break the bond between this carbon number 2 and carbon number 3. But oxidation of glucose, we get only what? Only 1 compound. It is gluconic acid. What about the reduction of the fructose? The reduction of fructose the same as the reduction of glucose. It gives us sorbitol, because if you add hydrogen to this one of them goes with this oxygen and the other one goes with this carbon. So you have to break this bond and insert hydrogen here and hydrogen here. So we will get the sorbitol. We don't write it here. The last point about the monosaccharides. All monosaccharides are reducing sugar. Do you remember what this means, reducing agent, in chapter 3? Yes, reducing agent, it is the substance that loses electrons. But what does it mean, reducing agent here, or reducing sugar? All monosaccharides are reducing sugar. That means, yes, they react with Benedict's or Fehling blue solutions. Benedict, the name of the scientist, and also Fehling, the name of the scientist. Both have different solution, but both also contain Cu ions. Cu plus 2 ions. It is what? It is blue. Yes, different compounds, but in their compounds they have also they have Cu plus 2 ions. This Cu plus 2, it is blue. When you add reducing sugar, this sugar is oxidized by losing electrons and give this electron to Cu plus 2 and reduce it to Cu plus 1. From Cu plus 2 to Cu plus 1. Cu plus 2, it is blue. Cu plus 1 is present in Cu2O. it is, brick red precipitate. So again, all monosaccharides are reducing sugar. They reduce Benedict solution and Fehling solution to brick red precipitate. Okay, how can you distinguish monosaccharides? Yes, all of them are reducing sugar. When you add Fehling solution or Benedict solution, this solution changes to what? Changes to the brick red precipitate, okay, by heating, by the way. So glucose is easily oxidized because of the aldehyde groups which contains hydrogen. That's why you call it reducing sugar. Look here, this example for the glucose, it has aldehyde group. This blue solution contains Cu plus 2. This is for the Fehling or Benedict solution. This is the color. Now, if you have, glucose, this glucose with Fehling solution or Benedict solution, oxidized to gluconic acid. Oxidized, it means loses electrons here. This electron is given to the Cu plus 2, change it from Cu plus 2 to Cu plus 1, and this is the color of the brick red precipitate of Cu plus 1. But Cu plus 2, it is blue, and there is no precipitate here, it is the color. Yes, here we will see, the precipitate or brick red precipitate, or sometimes you call it gelatinous red precipitate. And this experiment, we can distinguish glucose, fructose, and galactose from other sugars, and we will see, inshallah, in disaccharides we have also maltose and lactose. Also, they are reducing sugar, except saccharose in the disaccharides. Now we have experiment to detect the amount of sugar in your urine. Just take your urine in test tube, then add Benedict solution or Fehling solution. If you boil it, if you get green precipitate, that means you have small amount of sugar. Okay, so you are slightly infected person. If you get yellow precipitate, that means you have medium amount of sugar, so you are intermediately infected person. If you have red precipitate, so that means you have large amount of sugar, so you are highly infected person. If you have no change of the blue solution, that means there is no sugar. Okay, it means you are healthy person. Again, if you want to know the amount of the sugar in your urine, you have to take, urine and add Benedict or Fehling solution, then heat it. If you get green precipitate, so that means you have small amount of sugar. If you have yellow precipitate, that means you have medium amount of sugar. If you have red precipitate, so you have large amount of sugar. If the color doesn't change, that means there is no sugar. Okay, up to here we have to stop and see you in the disaccharides. Thank you.